Hi there guys, my name is Dan Slack, and as Andrew said, I'm a medical student that's intercalating in microbiology this year. I'm going to be talking to you today about antibiotic resistance, and more importantly why you should start to care about it. This is something that there has been a bit of media attention, but I feel it's still something that's pretty poorly understood, and as it affects everyone, I feel people should know more about it. So first of all, what are antibiotics? So they're chemicals that kill bacteria and only bacteria. That's really important to get across because there are loads of sort of microorganisms that cause disease. Viruses, parasites, fungi, things like that. Antibiotics don't do anything against those, they only kill bacteria. And they were discovered in 1928 by the man on the top right, that's Alexander Fleming. And he came into his lab one morning and saw that one of his petri dishes looked a bit like that. So you can see the streaks of bacteria, which are there. Infrared's cool. And then there's the big white blob there, which is a penicillium fungus. And he noticed this zone of inhibition around the fungus, and he thought that maybe the fungus was producing a chemical that was killing the bacteria. And he was right, he discovered penicillin, and that kind of approach of looking at microorganisms to find new antibiotics led to the discovery of many others and changed medicine in a huge way. You could suddenly treat gonorrhea within 4 days, syphilis was curable. And I think that's the really important point, that things weren't just treatable anymore, they were curable, and people could live long lives. It also had massive impacts on surgery. So what's the problem? So resistance started to emerge in 1940. So antibiotic resistance is the ability of bacteria that they've evolved to resist the antibiotics, so they're no longer killed by the drugs that we use. So it started to emerge in 1940. That's actually 2 years before the first clinical use of penicillin, which is in 1942. So it shows that resistance has always been a really big problem. So infections have started to become untreatable. Now, because resistance has been such a big problem, you might ask, why am I talking about it now? We've always managed to create new antibiotics to kind of fill the gap, as it were. So every time an antibiotic has become useless, we've plugged the gap with a new antibiotic. Unfortunately, no new antibiotics have been discovered since 1980. So that's 30 years where the drugs have only been running out. We haven't been getting any more. And this is really important because it can send us back to the 1920s in terms of healthcare, where tuberculosis, that's the treatment for tuberculosis there. It's just fresh air. There's nothing you can do about it. That's all they had. So to really appreciate kind of the problem, we need to look at what we use antibiotics for at the moment. So the obvious one is infectious disease. Simple chest infections wouldn't be treatable anymore. There'd be a death sentence. Skin infections, already quite bad, get even worse. STIs, there's a strain of super gonorrhea that broke out in Leeds last year. That's completely drug resistant, so there's nothing anyone can do about that if you get it. Surgery is one of the biggest uses of antibiotics. You can't really do surgery without antibiotics because you're opening the body to let bacteria in, so you need some way of fighting that off. So mortality rates would go back to kind of 18th century in terms of surgery. Childbirth, also a big user of antibiotics. It's very difficult to estimate how much women's mortality would go up by because gynecological medicine has increased a lot as well, but because antibiotics are so heavily used, you can assume that it would be quite dangerous. Cancer chemotherapy wouldn't be possible without antibiotics. You need that to protect them. The chemotherapy diminishes their immune system, so you need antibiotics to protect them against that. And for the same reason, human organ transplantation would be a problem. And one of the biggest uses of antibiotics is commercial farming. We use antibiotics in this to keep meat alive longer effectively, so that more can be kind of brought to your table. It lowers the cost. So not only does it have huge impacts on society, it also has massive impact on the economy. Is this our fault? Yes, it is, and for 3 main reasons. Number one is we overuse antibiotics, and by that I mean we give antibiotics to people who have viral infections or perhaps don't have an infection that's bad enough to require antibiotics. Second is we misuse antibiotics, that's patients. We take antibiotics not for the full course, you normally prescribe them for 7 days. Often people take them for 4 because that's when they start to feel better. And third is we pressure GPs to give antibiotics as well. 90% of GPs in a recent survey done last year said that they felt pressured to give antibiotics, and 40% said that they caved to that pressure. So how has this happened? Well, it's all to do with genetics and evolution. So one day a bacteria, like this little red one here, got an antibiotic resistance mutation. And bacteria are very good at passing the mutation between them, and they also divide very quickly. So evolution can happen a lot faster in bacteria because they divide once every 20 minutes or so. So antibiotic resistance probably would have developed anyway, but it would have taken a lot longer. What we've done by overusing antibiotics is we've sped up that process. So by overusing antibiotics, you basically, someone comes in with a virus and you give them antibiotics. The virus is fine, the person will get better on their own anyway. What you've done is expose the natural flora, the kind that appears in Yakult. You've exposed that, and now all of a sudden that has antibiotic resistance, which isn't a problem for yourself, but when your bacteria get into somebody else, that can be a real problem for them, and it can't be treated now. When we talk about misuse, by not taking a course of antibiotics for the full kind of 7 days, but only taking them for 4 days, the patient might feel better, but not all the bacteria have gone. And because you've exposed them to these antibiotics, now they can just come back, and they're all resistant now, so it can't be treated again. Can anything be done? Thankfully, yes. We can stop the use of unnecessary antibiotics, so we can educate those without scientific knowledge, so they don't put this pressure on GPs. Also, GPs really need to take the kind of onus here to stand up to patients. They're the ones with 5 years of medical training. They're the ones that really need to be saying, you've got a virus, I'm not going to give you antibiotics for this. We can use antibiotics responsibly ourselves, do what we're told, take antibiotics for the full 7 days if we need to. We can create more antibiotics. Only 1% of discovered bacteria at the moment are actually culturable, so there's a lot of kind of potential in looking for new bacteria to produce antibiotics for us. But this is just pushing the problem 30 years into the future. What we really need to do is design new ways of killing bacteria, and that's what my research is focused on and what a lot of research is focusing on at the moment. In particular, an interesting thing is this, a group at Nottingham recently translated an ancient Anglo-Saxon manuscript and found a recipe for a kind of drug that actually kills MRSA just as well as vancomycin, which is the current antibiotic we use to beat that. So my research focused on bacteriocins, and there are small proteins that kill bacteria, and they're produced by other bacteria. So it's the way bacteria fight amongst themselves. And they're very, very efficient killers, and they're very, very specific, so they only kill a few number of bacteria. And they're produced by many different bacterial species, from E. coli to the one I focused on, streptococcus pneumonia, which causes pneumonia. And they're a very powerful antibacterial agent because resistance mechanisms are perhaps unlikely to develop because they're so specific. So my research, as I said, focused on streptococcus pneumoniae, which is the main cause of pneumonia and causes a particularly high mortality rate in the very young and the very old. So it's a real problem. And what we wanted to do was to see the range of the bacteriocins and see if we could perhaps artificially increase production to make it clinically relevant. So to do this, we used something called an overlay assay, which is a bit like a bacterial fight. So we pitted one bacterial species against the other to see who won. So we put the blue bacteria in the bottom layer here, in agar, which is bacteria food, and then the red bacteria in the top layer. We left it overnight in an incubator, and then in the morning we wanted to see who won. So we often got this result here, which doesn't actually show up very well on the screen, but you might be able to see there's a little yellow stab there, and then surrounding it there's a kind of darker area, which is where inhibition has taken place. Trust me, it's there if you can't see it. I spent 30 days looking at them, so I can see them pretty well. So that is bacteriocin-mediated killing there. So that's proof that one bacteria can kill the other one. And then we added chemicals at various stages to see if they could increase the effects of the bacteriocin that we used. So what we found was that they have a wider range than expected. They kill a lot more bacteria than we originally thought they did, including some quite surprising examples. The chemicals we used inhibited production of bacteriocin, so probably back to the drawing board with that one. And it gave new insight into how S. pneumoniae competes in the human host, which was previously unknown information. And there's some of my results. They're, again, quite hard to see on the screen. So a quick summary. So not that far in the future, we could totally lose the use of antibiotics. That's 20 to 30 years, so it's not really that far in the future. And that's due to bacteria evolving to become resistant to them. And what can we do? We can stop giving antibiotics for viral infections. We can take a full course of antibiotics, and we can stop pressuring GPs to give antibiotics. Thank you very much. Are there any questions?
Thanks so much, Dan. Any questions? Yeah, yes.
With your method of using bacterial against fillers, how would it be applied as a medical treatment?
So it's very much in its infancy at the moment, as with all the kind of replacements for antibiotics. Ideally, what you'd want to do is, my methods were mainly qualitative, so we're just proving that the bacteriocin does work on certain strains. You need to do something quantitative to do that. Eventually, you'd have to try and extract, you'd have to do gene knockouts and things like that to prove what was actually happening was the bacteriocin. and then eventually you try and purify that and scale it up to a clinical level.
Thanks. Anything else? Yeah.
You mentioned in one slide that there are no new drugs since the 1980s.
Sure.
I think that the last antibiotic that was produced was in 2001 or something.
Sure.
And we already have antibiotic resistance.
Yeah, so antibiotic resistance occurs incredibly quickly. That's what we know. 2 years, even methicillin, I think, was brought in to tackle MRSA when that first appeared, and resistance to that appeared in 2 years. I believe, I might be wrong, but all the antibiotics that have been discovered since the 1980s are derivatives of others. I don't think there's any kind of new kind of categories, new actual methods, because all the antibiotics work in different ways, or different families. I don't think there are any new families, if you see what, does that answer your question in some way? Yeah. Sure.
Okay. Phoebe?
Do they stay resistant forever, or could it be that they mutate in such a way that they then are not anymore resistant to their antibiotics?
That's perfectly possible. They could lose their resistance. And there's actually a thing called fitness cost, which is where kind of beneficial mutations to bacteria can cause them harm as well in terms of nutrient uptake and things like that. But because of the process of natural selection, I think it's more likely that kind of good genes, obviously antibiotic resistance gene is a good gene for a bacteria to have. It's more likely that those things will stay if we keep misusing antibiotics. But in the future, if we're using different treatments, those genes might disappear and we can start using antibiotics again. So.
What are the medical community going to do when it does run out and when you can't make any more antibiotics? Because like things like pneumonia kills people like every day.
Yeah.
And once you've got illness like that, you have the medical community instantly. So how?
Yeah, you're totally right. That's why it's important, because there isn't really that much they can do. At the moment, there is a lot of research going into kind of replacements. So there's things called predatory bacteria that are being researched, which are bacteria you could inject into someone and they'd go and hunt down the bacteria you want them to kill. There are things like the Anglo-Saxon remedy. There's got quite a lot of manuscripts that have been kind of translated into kind of remedies. There's also things like bacteriocins that are being looked into that, and different proteins that are being looked into to kill bacteria. But they're all very much in their infancy. I must stress that if some antibiotics will still work, it's just you won't be able to predict when they'll work and when they won't. Not all bacteria will be resistant, although that is the way we're going eventually. So you're right to be worried, though.
Yeah.
You also said that antibiotics were given to animals. Does that then transfer to the meat that we eat and also cause problems, or is that knowledge?
I don't know too much about that. I believe that some kind of animal rights activists and kind of PETA and things think they do. They don't like chemicals being used on animals, and I assume that's the reason why. The real problem for commercial farming has been one of the biggest contributors to antibiotic resistance, just because of the sheer numbers of animals that are getting. Because, I mean, there are bacteria that can transfer from human to animal. And obviously, if you're making them resistant in animals and they transfer to humans, they're still going to be resistant. So.
Okay, cool. We say then again, thank you very much.
Thanks.